Okay, cool. I think it's working. This time I had to actually click go live again. Still very confused. Cool. Going to go through the senior round 2 paper from Thursday. And right off the bat, it's already harder than last year. They want you to solve an equation and not just do arithmetic, which is fun. Okay, so my you've probably noticed if you try to go into the SAMF's website that the question papers aren't officially available yet. So this is just a picture that someone sent me, except that it's only this page that I have in English, and all the rest was sent to me in Afrikaans. I'm going to have to translate too, which is great, but cool. First question, not too bad. 3a equals 55 minus 2b, 10 plus 2a is b. Multiply that by 2, and you get 20 plus 4a equals 2b. Add them together, and you get 20 plus 7a is 55. And then you get a is equal to 5, and you can substitute that back in. So b is equal to 20. And so if you add them together, you get 25. That's the final answer. Which is the numerator of the largest fraction below? Well, 500, come on, why is this? Okay, 500 plus x over 1000 plus x. Is this plus x? Why is this? Okay, picking up my hand when it usually doesn't. Is the same thing as 1 minus, so it's 1000 minus 500 over 1000 plus x. And so you see that the larger you make x, the smaller this piece is that you're subtracting. So this is going to be the largest of them. And the numerator is 504. So it's 25, then 504. The diagram shows a circle with center O. If the area of the shaded region is 15% of the area of the circle, what is the value of x in degrees? Well, x is 15%, come on, 15% of 360 degrees. 15% is 3/20ths. 20 times 360, a 20th of 360 degrees is 18 degrees, so this is 54 degrees. Question 4 is a little bit mean, because if you don't already know the answer, it's unlikely that you're going to, well, maybe, I don't know, maybe it's reasonable to expect you to be able to figure it out. So the answer is 2. If you've ever heard of the AMGM inequality, in other words, if you've ever attended a training camp where I had anything to say with what gets taught, no, the propaganda is strong, then yeah, you already know that your answer is 2, because a over b plus b over a over 2 is greater than or equal to the square root of a over b times b over a. Which is 1, and you can actually get 2 if a is equal to b. But I suppose if you've never seen this before, what they were anticipating you doing, no, I have no idea what they were anticipating. You'd have to, any proof that this is bigger than, like finding the minimum here is already, you'd already have to guess that 2 is the value. If you knew that you wanted to show that it's greater than or equal to 2, you know, this minus 2 is a squared plus b squared minus 2ab over ab, which is a minus b squared over ab, which is greater than or equal to 0. But that, you know, like you can only do this if you were already expecting the answer to be 2. So I guess if you had to do it from scratch, if you looked at the function, except that this is intended for, I don't think that they intended for you to like, I doubt that the intention was to, you know, differentiate this and set it to 0 to figure out where the maximum is. Maybe that is what they were expecting. 1 minus 1 over x squared. So x equals 1 at the maximum. So the not maximum, minimum. So minimum's 2. So I guess that's an option. But that's not what they were anticipating if this is question 4 on the paper. They were expecting you to just look at this and know the answer. And unless you already had reason to suspect that the answer is 2, I don't know what they were hoping for. I guess plug in, I don't know. There's not too much to say about it because if you do know the answers 2, then it's easy to show that this is bigger than or equal to 2. And if you do know like AMGM, then this is, well, then you already know that this is bigger than or equal to 2 anyway, because this is the first example anyone ever shows you. If anyone's got any thoughts on what the from scratch approach is that doesn't use calculus, because this is question 4 on the round 2 paper, then let me know. I mean, I guess you could draw the graph of x plus 1 over x, then you know it looks like, I mean, you know it looks something like that, but like again, why, how do you know that? No, it doesn't actually. It does, it goes upwards again. It's like that. I don't know. Surely it goes upwards again here because it's a metric about x equals. Not quite, but there is like a, I don't know, whatever. I'm not going to dwell on it for too much. Okay, calculate the angle x in degrees in this figure. So the person who I got this from helpfully called some angles A. If that's x, then this is 90 minus x over 2. And this is 90 minus x over 2. X over 2. And this is 30 minus x by exterior angles. And you know that those... actually, this doesn't help. Yeah, it's like automatically true that, oh, we know that 30 minus x equals 90. I was going to say the angles in a triangle add up to 180, but that's redundant information. That's already captured by these values we filled in here. So that's not going to give you... But the equation that you want is that in this isosceles triangle, that 30 minus x, come on, is 90 minus x over 2. So x over 2 is... That doesn't make sense. This is x minus 30, sorry, not 30 minus x. Yeah, I was going to get x has got a negative value in the equation I was going to set up, and that doesn't make any sense at all. So x minus 30 is 90 minus x over 2. So 3x over 2 is 120. And so x equals 80. Does that work? If this is 80, this is 80 degrees, this is 20 degrees, and this is 10 degrees. 161. No, that doesn't work. Oh, sorry, x is this. This one is the 80 degrees. These are each 50. And this one is 50. Yeah, that works. Okay, that makes much more sense. Can't do maths today. Cool. Now we enter the Afrikaans section of this presentation. So I want question. No, sorry, the next page I've still got in English. It's only questions 11 onwards that we are... Oh, no, I do have English translations for all of them. Oh, I thought the person had sent me the whole thing in Afrikaans, but I guess... Never mind. You don't have to suffer through me butchering that language today. Okay. It is rotated though, and I haven't figured out how to get the software to rotate the image. And it's going to be too much effort to first put it into Photoshop, use that to rotate it. Tools, is there a rotation tool in the tools? I don't see one. Cool. We're just going to have to read sideways. Soz. Come on. Okay, what is the sum of the digits if this number is calculated? So, This page down here, I'm like inserting pages in the wrong place. Let's go down here. Let's create a new page afterwards and keep everything in a sensible. Yes. So the question is, what is the sum of the digits of, what was the number? 2 to the 2024, 5 to the 2026. And I think the point here is to realize that you can combine this into 5 squared times 10 to the 2024. And so this is 25 and then a whole bunch of zeros. And so if you add up all the digits, you get 7 as the answer. Okay, calculate the, oh, that looks horrendous. Okay. Calculate the cube root of 25 plus the fourth root 25 plus the fourth root of 14 plus the square root. How is this going to be a nice just normal number at the end? 14 plus the square root of 2 plus the cube root of 8. Oh, that's fine, because the cube root of 8 is a 2, and then the square root of 4 is 2, and then the fourth root of 16 is 2, and then the cube root of 27 is 3. Okay, so it just looks horrible, but it's actually very straightforward. 2 plus the square root of, was that a square root? Cube root of 8. Okay, usually they put the arithmetic question as question 1, but I guess today they think that the arithmetic is complicated. Or Thursday in the year 2024. So this is just 2. So the square root of 2 plus 2 is the square root of 4 is 2. Then the fourth root of 14 plus 2 is the fourth root of 16, which is 2. And so then we're looking for the cube root of 27, which is 3. And so the final answer for this question is 3. Okay, 3 for this. 24 Martians numbered 1 to 24 stand in a circle in clockwise numerical order, all facing the center. They begin calling numbers out loud in clockwise order. The first Martian calls out the number 1, the second one calls out the number 2, and each one thereafter calls out the number 1 more than the previous number which has been called. What is the number of the Martian who calls out the number 2024? Okay, so the first one calls out, yeah, they numbered 1 to 24. 2024 is 24 times, well, the question is just what's the remainder when we divide 2024 by 24. So 2024, come on. Come on. Okay, well, I don't really feel like dividing by 24, but dividing by 25 isn't too bad. So 100 is 425, so 2025 is 20, so 80, 81. 81 times 25 minus 1, I think that's right. So it's 2000, yeah, 2024, and this is almost 24. This is 81 times 24 plus 81 minus 1. And so we actually just want what's the remainder when 80 is divided by 24. So that's 3 24s gives us 72. So this is 84 times 24 plus 8. So I think, yeah, the remainder when you divide 2024 by 24 is apparently 8. Does that make sense? Is 2016 divisible by 24? Well, it's divisible by 8 and divisible by 3, so yes it is. So this is correct. So yeah, so we're going to have we're going to go around the full circle 24 times. Full circle 24 times, and then the 8th Martian is going to call out the 2024th number. 84 times. And the 8th Martian calls out the 2024th number. Calls out 2024. Okay. Yeah, it's weird. They're putting all the arithmetic questions between question 6 and 10 by the looks of it. Okay, what is the largest value of x such that 2 to the x divides exactly into 19 factorial? So yeah, how many factors of 2 do we get? There's a standard way to do this, but if you haven't seen it, then I guess I should explain what on earth I'm doing. There is, in this list, there are 9 multiples of 2, and each of them gives us one factor of 2 in the prime factorization of this number. There's also 4 multiples of 4. And for each of those, we've only counted it as a multiple of 2. So we've said it contributes 1 2 to the overall product, but actually it contributes at least 2 2s. So for each of these, we have to add in an additional 2. And then there's 2 multiples of 8 and 1 multiple of 16. So the multiples of 8, we've already accounted for 2 of the 2's that they contribute. Once as a multiple of 2 and once as a multiple of 4. And so they contribute another 2. They actually contribute at least 3 2's in total. So we have to add in another 2 for each of the multiples of 8. And then there's 1 multiple of 16, which actually contributes 4 2's. But we've already counted 3 of those 2's. Once when this number was a multiple of 2, once as a multiple of 4, and once as a multiple of 8. And so we expect to see 13, 15, 6, 2 to the 16 is the largest power of 2 that divides this. But we can write this out more explicitly. 19, 18, 17, these are the numbers we're multiplying together. So if you don't understand what I just did, 8, 7, 6, 5, 4, you get the same answer if you literally just go and write it all out. This one is 2 to the 1 times 9. This is 2 to the 4. This is 2 times 7. This is 2 squared times 3. This is 2 times 5. This is 2 cubed. This one's 2 times 3. This one's 2 squared. And this one's just 2 on its own. So here we've got 1 2, another 4 2's. So that's 5 in total. 6, 8, 9, 12, 13, 15, 16, which is the same answer as what you would have gotten over here, 9, 4, 2, 1. You can see that for every second number, there's at least 1 2 in that factorization. For every fourth number, there's actually at least 2 2's. So we have to add it in a second time to account for the second 2 that exists in this factorization. For every 8th number, there's actually at least 3 2's. And for the 16th number, there's actually 4 2's. And so, yeah, that's where the 9 plus 4 plus 2 plus 1 comes from. Looks like, yeah, this doesn't look like it's going to take that long, actually. 10 people stand in a row. The first person goes to the back of the row and the next person leaves the row. So the person who was third in the row is now first in the row. Now the person first in the row goes to the back of the row and the next person leaves the row. This is repeated until one person remains. What is the original position of the row with only one remaining person? If they wanted to make this difficult, they could have started with like 2,000 people. Then it's a common problem. Well, it's still a common problem called the Josephus problem, but it's a small version of it where we can literally just work this out explicitly. And that's probably, in this case, the quickest way. So that's what I'm going to do. But if you want to look it up for your enrichment, this is called the Josephus problem. So we're starting out with 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay, so one goes to the, is it one goes to the back and then 2 leaves? Or is it 1 leaves and 2 goes to the back? The first person goes to the back and 2 leaves. So then you can see that in the first round, all the even numbers are going to leave. 1 is going to end up at the back, and then 2 leaves. Now 3 is in the front. Then 3 is going to go to the back. So this is what the back of the queue now looks like. And then 4 leaves. And then 5 is going to go to the back. And 6 leaves. And then 7 is going to go to the back, and 8 leaves. And then 9 is going to go to the back, and then 10 leaves. And now we're at what was the back of the original queue. So this is what our queue looks like now. Now, the first person is going to go to the back. Oh, I think the first person might just be the one that survives. Then the 3 leaves. Then the 5 goes to the back. The 7 leaves. The 9 goes to the back. And now the 1 leaves. The 5 goes to the back and the 9 leaves. And so the 5 is the one that's left over. 5 for this question. And that's everything below 10. Now question 11. Where's my copy of question 11? 11. Ah. Yeah, cool. Copy image also rotated. This time in Afrikaans. So in die stel loodregte lynsegmente hiernaas vertoon, Dutch is corrupting my brain, is AB gelyk aan 10 en elke ander segment is 1. Eenheid korter as die vorige een. So BC is gelyk aan 9, CD is gelyk aan 8, DE is gelyk aan 7 en sovoorts. Wat is die kwadraat van die lengte van die lynsegment AK? Okay, so in this beautiful picture over here, what the translation of this thing is, loodrecht I think just means orthogonal. Like lood is lead, but it's if you've heard of a plumb line in English, that's supposed to be something that hangs straight down. So AB is given to be 10. I did not switch to the eraser. Why is this? Okay. AB is given to be 10, and each other segment is 1 unit shorter as the previous one. So BC is 9, CD is 8, 7, 6, 5, 4, 3, 2, 1. And so the question is, what is the length of the square of the length of AK? So we are looking for, do those actually lie on a straight line? I'm not sure. But basically, we want the square of the length. So Pythagoras just tells us we have to work out what this length is here. So the difference in the y coordinates, so to speak, of these points, and the difference in the x coordinates. If you really wanted to, you could just set up some coordinates. If this was 0, 0, this could be 10, 0. Then this is 9 down, so this is 10, 9. This is 2, 9. Then this is 2, 2. Because we're going 7 up. Then we're going 6 across, so this is 8, 2. Then we're going 5 down, so this is... Oh, I've like flipped this from what the usual convention is. I'm going bigger y values going further down, but okay, pretend all of these y's have got a minus in front of them. It doesn't actually matter. So, but let's keep with the convention I unintentionally adopted. 4, 7 over there. We go 3 up, we get to 4, 4. And then we go 2 across and we get to 6, 4. And we go 1 down, so we get to 6, 5. But if you wanted to think of it in terms of lengths, I think coordinates is actually the most natural way to think of this. But we know we're going 10 across, so we are 10 to the right of where we started. And then we're coming 8 units back, so now we're 2 units to the right. And then we're going 6 units across, and now we're 8 units to the right. And then we're coming 4 units back, so now we are 4 units to the right. And then we're going 2 units across, so we are 6 units to the right. Right, so this length here is 6. And then the same thing happens in the vertical direction. I mean, I'm just saying the same thing as what I did when I wrote down the coordinates, but I mean, it's... So I don't know if there's really any point in repeating it, but cool, we're going 9 units down, so now we're 9 down from where we started. So we go 7 back up, and so now we're 2 down from where we started. It's the 9 minus 7, and then we're going down again by 5. So it's the 2 plus 5 units down is 7 units down. Now we're going 3 units up, so now we're 4 units up. And then we're going 1 unit down, so now we're 5 units down. And so this length here is 5. And so then by Pythagoras, AK squared is 6 squared plus 5 squared, which is 36 plus 25, and that's 61, unless I can't do arithmetic. Yeah, that is 61. Okay. Question 12. Let me just find the picture. Okay, here we go. This is now the equations page in this paper. Still Afrikaans. Oh no, this is English again. I don't know. Did I get this from 2 different people, or was one person really just inconsistent in what they sent me? I just saw the pictures show up, so I can't actually remember exactly who sent what. Otherwise, I'd give you all the credit. In the table, the product of the positive integers represented by the letters in each row and column are given. So xy is equal to 9, and xz is 45. Who is messaging me? Okay, I'll get back to them. So xy is 9 and xz is 45. What is the value of xw? So let's redraw this table, or actually I'll just write down all the equations you can get from it. So xy is equal to 9. Xz equals 45. Zw is equal to 80. And yw is equal to 16. Yeah, I think that's everything you get from it. And the question is, what is xw? That's a good question. You can get xw times y squared is 144, but there isn't an independent way to work out y squared over here. So we might have to use the other bit of information they gave in the question, which is that these are all integers. But usually when you get this kind of thing, it all just like, you can multiply some of these together and then divide by something else, and it all just cancels out nicely. The kind of question I have in mind is the kinds of question where they say we've got a cube and they give you the surface area of each of the sides and then ask for the volume. And there it turns out you can't work out the sides individually. But if you multiply the three different surface areas together, you get the square of the volume. Just because of algebra. So I was hoping, yeah, that like something similar would happen, that I could take, because I want the xw. So, if I multiply that by that, so I've got the x and the w together. Although I do know what xyzw is. So if I then knew what yz is, I don't see a way to work that out either. I don't think we need to... Well, x is a common factor of 9 and 45, for example, and y is a common factor of 9 and 16. So y must be 1 if these are integer or negative 1, although they say positive integers. So I'm wondering, I wonder if this question's actually only solvable if we use that these are positive integers, or if this was meant to just be some algebraic manipulation. But cool, let's use all the information they give us. So since y is is that right? Xy is 9, that's correct. And yw is 16. So yeah, y is a factor of 9 and 16. So y is equal to 1. 9 is 3 squared, and 16 is 2 to the 4. So the only prime factors of 9 are 3, and the only prime factors of 16 is 2. And so they have no prime factors in common. So they have no factors in common at all other than the 1. They are relatively prime. So that's why I can say straight away that y is 1. And that just tells me that, yeah, x is 9 and w is 16. And so I can multiply those, and xw is then 144. I mean, this does actually work. If you take w is 16 and, z is 5, and that works, that checks out with x is 9 and z is 5, gives us the 45 that you expect. Y times w is then 16 by, I mean, that's how we got the value for w in the first place. So yeah, xw is 144. And we probably have to actually use that they're integers, otherwise I'm not sure that the value of xw is uniquely determined otherwise, but it doesn't really matter. We've got an answer, so we can carry on. The mug shop keeps all kinds of different interesting mugs. The shopkeeper starts working at 8 a.m. and stops at 1 p.m., so that must be nice. A certain collection contains 6 mugs put next to each other on a shelf. Okay, let's see if we can. That's a mug. Totes a mug. And that's a mug. And we've got 6 of these things. Dot, dot, dot. Here's our last mug. Let's give them numbers. 1, 2, up to 6. So that's our shelf. It takes 55 minutes to arrange all of the remaining, but I mean, we haven't done it. Okay, whatever. I'll assume that there's a reason for that word being there, because I would have assumed all 6 mugs of this collection in all possible different arrangements. If he starts arranging the mugs from this collection exactly on the hour every hour, and 1 mug from this collection gets sold in the last 5 minutes of each hour, how many okay, so so that's why the remaining is there. I think every time a mug gets sold, in the next hour he then takes all the mugs that are left and starts arranging them in every possible order. So in the first hour he puts these in all 720 orders that you can arrange 6 items. And so that's between 8 and 8:55. He does 720 arrangements. And then between 8:55 and 9, 1 mug gets sold. Okay, so between 8 and 9, he makes 720 arrangements. So that's from 8 to 9. And then between 9 and 10, he makes 120 arrangements, which is 5 factorial. That's the number of ways of arranging 5 mugs on the shelf. Then 10 to 11, he does 24 arrangements. 11 to 12, well, actually until 11:55, and then 1 gets sold. He does, so yeah, there was 6, 5, 4, there's 3 arrangements, so that's 6, or 3 mugs to arrange, that's 6 arrangements. And then 12 to 1 p.m. There's 2 mugs left, so he does 2 arrangements. Yes, and then 1 gets sold, and then there's 1 mug left, but he stops working at 1 p.m. because, I don't know, I guess never mind, I won't engage in needless stereotypes. He's from insert group here that is stereotypically doesn't work much. So the total number of times he arranges these mugs is 7, or total number of arrangements he makes, 720 plus 120 plus 24 plus 6 plus 2. So that's 30, 150, 872. Hope that's right. Yeah, 150, 872. I think that's the answer for that question. The wording's a bit weird, but that's fine. How many 9s are there in... How many 9s are there even in that number? Is that 5 9 squared after it has been calculated? Okay, so in the digits, how many nines? Nines in 99999 squared. I mean, the first thought that I have is that this is 10 to the 5 minus 1. And so we're squaring that. And so we're going to get 10 to the 10 minus 2 times 10 to the 5 plus 1. And if you imagine actually doing that, you know, the subtraction, here's 10 zeros. And then we're subtracting 2 with 5 zeros. And then we're adding 1 at the end. But when you do the subtraction, initially we're just subtracting 0 from 0. And then we're going to, so that's 5 zeros. So here, there's 1 and, okay, so there's 6 digits to go. There's 5 more zeros. Yeah, so we're going to have the 0 minus 2 is going to be an 8. And now all of these zeros are actually 9s because we borrowed this 1, made this a 9, made this a 9, made this a 9, and so on. And so there's 5 9s. Oh, the 4 9s and a 10, but there's 5 digits over here. Yeah, 4 9s and a 10. So the 10 minus 2 is 8, and then there's 4 9s. I think, and then we're going to add 1. So we're going to end up with 9, 4 9s, 8, 4 zeros, and a 1. Why is this not writing? 99998000001. I guess the other option that you have for solving this question is working out a few small cases and then hoping that the pattern that you spot extends. If you really wanted, you could work out 99 squared, which I don't feel like working out, but I imagine it's going to be 9801. Because I mean, this pattern does actually continue, and if you were unfortunate enough to work that out, then 998001, and then you might have guessed, okay, maybe we add a 9 and a 0 each time. I don't know. But like, if you're going to go through that much effort calculating these, then you may as well just calculate 9999 the long way round. You know, take this, multiply by 9999. You know, then you may as well just do the whole thing. So this is, I don't recommend this approach because then you may as well just jump straight to this calculation. So I think this was the intention, is realizing that it's 10 to the 10 minus 2 times 10 to the 5 plus 1, and then thinking about what happens if you actually were to carry out the subtraction. That we're gonna, you know, we're gonna borrow, we're gonna have a bunch of 9s. The 10 minus the 2 gives us an 8. And then the 4 9s don't, yeah, the 4 9s we just get zeros. I mean, if you have better options for how to do this, I would be interested, but I mean, that's not too bad. A train moving at a constant speed takes 4 seconds to cross the equator. That's either a small train or a fast train. It completely passes a platform 75 meters long in 9 seconds. So that's a slow train. What is the length of the train in meters? Okay, so I forgot what the numbers were that they gave us, but here's the equator. Definitely a real thing. Here's our train of some unknown length. Length, let's call it x, because you spell length as, yeah, this is x for length. That's how you spell length. It was mostly just because L is such a horrible letter to use. Okay. Takes 4 seconds to cross the equator, so it moves x meters in 4 seconds and x plus 75 meters in 9 seconds. So x meters, because to cross the equator it has to travel x meters. It's starting here and then it ends up in this position. So it's the front of the train is now x meters further along. So x meters in 4 seconds. And then x plus 75 meters. And I've already forgotten the number. Was it 9 seconds? I don't want to keep scrolling back this far. 9 seconds. Yeah, that is right. In 9 seconds. Because again, here we have the platform. And here we have the trains floating above the platform initially, obviously, because that's how trains work. They levitate. Maglev is totally production ready and cheap and efficient and reliable. Yeah, so here's our train. So this is 75 meters. So initially, I think the way to interpret the question is that the train starts out like that and ends up floating above the platform on the other. Oh, okay, there's rails over there. It passes the platform. The platform's where the people stop and wait. The platform's not where the train moves over. So in fact, it passes next to the platform, I guess. Anyway, it doesn't matter. This question's not about how trains work. It's the point is that the front of the train has moved this 75 meters plus X meters because we want the train to completely go past the platform. And so we get that it's moving at a constant speed, and its speed is distance over time. So X over 4 is equal to X plus 75 over 9. And then you can solve that. You get 9 minus 4, 5x equals 75. Is that right? No. No, it's not. It's 4 times 75 is 300. So x is equal to 60. The train is 60 meters long. Yeah, 135 over 9 is in fact 15. So this does actually work out. So the train is 60 meters long, and it does 60 meters in 4 seconds, which is that fast? It's 15 meters a second. So that's like 6 seconds for just over 6, between 6 and 7 seconds for 100 meters. That's only like 40 kilometers an hour. That is, yeah, like I said, this is a slow train. Um, although 60 meters I think is quite long for a train. I don't know. I don't have intuition for how, well, I expect trains to be faster than that. I don't know how long I expect a train to be. I'm actually going to, instead of scrolling back the whole time, I'm going to paste this page in again. And so now I only have to scroll to the top of this page instead of 6 pages back. Let x and y be real numbers in those equations, which looks like if you add them together you get x plus y cubed, and subtract them you get x minus y cubed. So that's exactly what I'm going to do and hope for the best. Because if I know x plus y cubed, I get x plus y is the cube root of that. And if I know x minus y cubed, then x minus y is the cube root of that. And so, if you know x plus y and x minus y, then you can work out x and y. So let's write this down again. We've got x cubed plus 3x y squared is 28. Although it looks like in this case, if you add them, you get 54, which is not a cube. So I'm not expecting nice values for x and y. So maybe this is not the best approach, because we're going to be working with the cube root of 54. I was hoping if I add them, I'd just get a nice number like 64 or something, so I can say x plus y is 4. But let's see how this works out. If I add these, I get x plus y cubed, which if you don't know is x cubed plus 3x squared y plus 3xy squared plus y cubed is 54. And if I subtract them, I get x minus y cubed, which is x cubed minus 3x squared y plus 3xy squared minus y cubed, which is exactly the difference between these two equations. So that's good news, is going to be 2. And so we get x plus y is the cube root of 54. Although one thing, the 54 is divisible by 27. So this is 3 cube root 2. And the x minus y is just cube root of 2. So I guess we can work out that x is 2 cube root 2. And y is equal to cube root of 2. Yeah, that's nice. That works. And then the value of x to the 6 plus y to the 6. So x to the 6 plus y to the 6 is going to be 2 to the 6 is 64. And then the cube root of 2 to the 6 is 2, so this is 128. Well, okay, let's write it out in detail. 2 cube root 2 to the 6, which is 128. Plus cube root of 2 to the 6, which is 4, is going to give us 132 in total. Is that right? So 2 to the power of 6 is 64. And then we're multiplying that by, it's not 128. 2 to the 6 is 64. And then we're multiplying by 4, so it's 256. Plus, this is still 4. We're going to get 2 squareds. This is 260. I hope that's right. Yeah. So this is 4 times 64. Yeah, and we get 65 times 4 at the end. Yeah, this is reasonably confident about that. Okay, that's the last question on that page. So let's go track down question 17. Question 17. Where are you? 7. Back to Afrikaans. Jill en Jack se huise. Oh, se huise. Dutch is again corrupting my brain. The Dutch pronunciation of huis is actually house, like basically the same as the English word. So Jill en Jack se huise is aan die teenoorgestelde punte van die park gelegen. Jack ry per fiets na Jill se huis op die paaie wat in die park uitgelê is, soos in die diagram aangedui. Op hoeveel verskillende maniere kan Jack na Jill se huis toe ry as hy slegs noordoos of noordoos beweeg? So you can move north, east, or... Okay, translation. Jack and Jill's houses are on opposite points of or opposite corners of a park. Jack rides his bike to Jill's house on the paths that are laid out in the park as in the diagram, or as shown in the diagram, as given in the diagram. In how many different ways can Jack cycle to Jill's house if he can only move northeast or northeast? So he can move this way, or north, or northeast on each step. So if you haven't seen this kind of thing before, the general way to approach this is for each of these points, work out how many ways there is to get to that point. And you do that by considering the total number of ways for all the points you could have come from to get there. So to get to this point, we had to have come from the west, because there isn't anything to the south or the southwest that you could have come from to get to this point. So there's only one way to get here. This point that we can come from the southwest. Let's pick a different color. We can come. I'm not pressing the eraser button. I hate technology. We can come from the south or the southwest. And so that's two different ways that we could have got here. The one way that we could have gotten here, and the one way to get here from the start. So there's two ways to get there. To get to this point over here, let's actually give it another different color. We could have come from the west, and that's it. So the only way to get here is to use the one way to get to this point over here, and then take another step east. So there's one way to get here. To get to get to, let's say, this point over here, we could have come from the south, or we could have come from the southwest. And so we can use the one path there is to get to this point, and then just take a northeasterly step. Or we could have used the one path there is to get to this point, and then take a northerly step. And so that's two different paths to get there. And then the most interesting one so far in this diagram is going to be this point over here, because we could have come from the southwest or from the south. So we could have taken either of the two paths to get here and then taken a northeasterly step, or either of the two paths that gets us here and then taken a northerly step, and that's 4 paths in total. And for each point, you're going to do the same thing. You're going to add up the number of paths to each of the points that could lead to this path. So the number of paths from the south or from the southwest or from the west. And so for this one, there's one way to get there. There's the one path from the west. For this one, we could have come from this one path or this one path, so that gives us 2. For this one, we had to come from here, from the east, from the west, so there's the 4 paths that get there and then take an extra step. This 2 was wrong because we could also have come from the west. So there's the one path from the southwest, the one path from the south, and the 4 paths from the west. There's actually 6 total paths to get here. For this one, it's the 4 plus 4. Come on. For this one, there's 6 plus 4 plus 8 is 18. Come on. And for this one, there's 26. And so there's 26 ways for Jack to get to Jill's house. Although why they have it as Jill and Jack and not Jack and Jill is, I don't know. It's unacceptable. What a strange language. Okay, we are given that f of 1 is 1 and f of n is n plus f of n minus 1 for all natural numbers greater than or equal to 2. Determine f of 30. I mean, there's only, you could just apply this formula 30 times and hope for the best. You could try to spot a pattern. So f of 2 we saw is 2 plus f of 1 is 2 plus 1. I'm going to deliberately not simplify it because I can already see what's going to happen. F of 3 is 3 plus f of 2 is 3 plus 2 plus 1. F of 4 is 4 plus this thing, so 4 plus 3 plus 2 plus 1. Yeah, but I think this is correct. And so f of n is n plus n minus 1 and so on plus 2 plus 1, and that's going to be n times n plus 1 divided by 2. I think this formula is a lot easier to spot if you had this than if you tried to simplify on each step, because then you'd have to recognize, well, I don't know, maybe you recognize triangular numbers, maybe you know that 3, 6, 10, 15, 21, 27, and so 28. Now maybe you'd recognize that sequence if you saw it. Anyway, this means that f of 30 is 30 times 31 divided by 2. So that's 15 times 31 is 456. 456. $66. I can't do maths. It's 450 plus another 50. 450, 465. I'm going to claim that, yeah, that's what I said all along. It's, yes. Yeah, okay, 450 plus another 15. Yes, 465. All right. Why have I got this? Okay, then I've got the same question, but in English this time, but we just did it. So, okay, 30 times 31 divided by 2. 15 times 31. 450 plus 15. Yeah, okay. I think I've got it right now. The circumcircle of square ABCD has radius 10. Yep, like the pencil marks over there would indicate. A semicircle is drawn on AB outside the square. Determine the area of the shaded region. Okay, well, this thing in purple over here is 1/4 of the full circle. So this has area, a quarter of 10 squared times pi. Pi times 10 squared, so that's 25 pi. This triangle in blue over here, if this length is 10 and this length is 10, then this whole length is 10 root 2. Oh, this is a 90-degree angle in the middle, so I don't actually have to work that out. I was going to work this out and work the height out and multiply this by this height, but actually I've got this side and this side I can use. So this area of the triangle is a half of 10 times 10, which is just 50. Which means that this piece over here is 25 pi. Color is not good. 25 pi minus 50. And we want to subtract that from the area of this, which is half of a circle of radius 5. So the area of this blue region is a half times pi times 5 squared. No, it's not radius 5. I'm being stupid. I do actually need to know this is now 10 root 2. So it actually didn't hurt earlier to work it out. So it's a half times pi times 5. Okay, that color is not going to work. 5 root 2 squared, which is 25 times 2, but then I take a half, so this is 25 pi. Probably could have predicted that because we know it has to cancel out with the 25 pi in this formula because the answer has to be a integer. So yeah, so the area of this light blue semicircle is 25 pi, and then we're subtracting this green circular cap, and so we get 25 pi minus 25 pi minus 50, which is just 50. Okay. Burgers are sold plain or with any selection of available toppings. Burgers with a different selection of toppings, including none. Why would you buy a burger with nothing on it? A nothing burger. Burgers with a different selection of toppings, including none, are considered different types. If Rocco Burger, is that infringing Rocco Mama's trademark? I don't know. Has 192 more types of burgers than Burger Bry, and Burger King is probably more litigious. Well, who knows? But uses only 2 more toppings. Well, okay. How many types of burger does Burger Bry have? So that Rocco Burger has got more types of burger. So let's say Burger Bry has n toppings, which means that they have 2 to the n possible burgers. And then, well, they tell us that Rocco Burger has got n plus 2 toppings, but I think you actually could have worked that out based on the other information. So I think that's actually redundant information, but cool, we'll use it anyway since we have it available. Toppings. And so we have 2 to the n plus 2 burgers. The reason I'll mention later why I think it's redundant. Burgers. And so we are given that the 2 to the n plus 2 minus 2 to the n is 192. And so we can factor out, we get 2 to the n times 2 squared minus 1 is 192. And this is 3. So if we take 192 divided by 3, you get 64. And so the number of toppings that Burger Bry has is 6, and the number of possible burgers is 64. So I guess the answer that they're looking for here, because they ask for types of burgers, is 64. The reason I say that they don't actually have to tell you that this is n plus 2 is if you want to solve in general, 2 to the m minus 2 to the n is 192. And we factor out the 2 to the n. So we get 2 to the n times 2 to the m minus n minus 1 is 192. And so this is a power of 2 and this number is odd. And so this must be the power of 2 that appears in the prime factorization of this number, which we saw already is 2 to the 6 times 3. So, you know, by the uniqueness of prime factorization, this is the power of 2 in this prime factorization, and this is the odd number that, you know, is made up of the rest of the factors. Every number is uniquely a power of 2 times our odd number, so we must have that 2 to the n equals 2 to the 6, even without knowing that m is n plus 2. It's forced based on this information. So I think maybe they gave the redundant information to make it faster to solve the problem. Maybe they didn't realize it's redundant. No, they must have realized it's redundant. At least hold them in that much esteem. Okay, let's find 21. Copy. Paste. Still rotated. Okay. Een vierkant ABCD is die figuur, I don't know, hiernaast lê punt G op AD en punt E op AB sodanig dat AE gelijk is aan BE. So, okay, that first very long sentence is in the square ABCD, in the figure here next to this. The point G lies on AD and E on AB, such that AE is equal to BE is equal to 3. Okay, so exactly what's in the diagram. The line segment GE, extended, meets CB extended in point F, such that EGC is equal to BCG, so that this angle is equal to that angle. So this triangle is isosceles. What is the area of the colored in region or section, portion of the diagram? Okay, let's draw this more nicely. Or maybe not more nicely, but let's redraw it. We've got this, we've got that angle equals that angle, we've got 3 and 3. We've got right angles everywhere. This side is a 6, this is a 6, this is a 6. So I suppose if we know that this length is the square root of 3 squared plus, do we know what this side is actually? I don't think so. It would have been nice. Yeah, we need this length if we want to be able to set up an equation. Do we need two variables? Do we want similar triangles? I think, yeah, similar triangles will work. This angle equals this angle. So, okay, I've got which points were labeled what? A, B, C, D, E, and F. I think if we call this x, so that this is the square root of x squared plus 9 by Pythagoras. And what we're being told is that, let's call this y. Then, oh, these triangles are just, they're congruent. Yeah, because this is, this corresponding side over here, this 3 is equal to this 3. And then we've got, they're similar because they have all the angles equal, and then they have one corresponding side equal, so they're congruent. So actually this length is also square root of x squared plus 9. And so because the big triangle is isosceles, we get that x plus 6 is 2 times the square root of x squared plus 9. And then square it, I guess, so x squared plus 12x plus 36 is 4 times x squared plus 9. So 4x squared plus 36, and the 36 is going to go away. And so we get 3x squared minus 12x equals 0. So x, divide the whole thing by 3x, x minus 4, maybe this whole thing times 3, I guess, if you really want to, is 0. So x is 0 or x is 4. Well, x is clearly not 0, so we must have that x is 4. Which makes this side over here 5. And this side over here 5, so that the total length of each side is 10, so that works out. Then what were they actually asking us for? The area of this thing over here. So that's going to be I guess it's the area of the square minus this triangle minus this triangle. But then unless there's an easy way to get the height of this triangle, but that's looks like it might need trig, which I don't want to do. Okay, if this is a 5 and this is a 3, this is a 4, because again these triangles are congruent, so fine, let's use that information. So that's a 3, 4, 5 triangle. Then this side is a 2 because the total has to be 6. Yeah, so this is fine. So this area here is 6, and this area over here is also 6. So we're looking at 6 squared minus 6 minus 6. So 36 minus 12 is 24, I believe. Okay. Given the sequence that's defined by ak is 1 over k squared plus k for k is greater than or equal to 1. Consider the sequence defined in that way. What ak is 1 over... Okay, let's paste again so I don't have to scroll as far. So ak is 1 over k squared plus k, which, because this is the only... because they've used this a million times, it's probably going to be relevant that this is 1 over k minus 1 over k plus 1. Given that yep, definitely, because now we're going to sum these and you get the telescoping sum. So that's definitely what you want to do. Okay, given that am, come on, why is this not writing? am plus 1, and so on, up to an minus 1 is equal to 1 over 29. For some positive integers m and n where m is less than n, yeah, I think that's clear from the context, determine m plus n. Okay, and we saw this is 1 over m minus 1 over m plus 1 plus 1 over m plus 1 minus 1 over m plus 2 and so on, plus 1 over n minus 1 minus 1 over n. And then the point is that everything here cancels out. This minus 1 over m plus 2 with something in that dot dot dot, something in that dot 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 with this plus, and you're just left with the extreme terms. So actually we've got the equation 1 over m minus 1 over n is 1 over 29. And so we get n minus m is 29 times n minus m is equal to mn. Yeah, okay. And so this gives us m minus 29, n plus 29 is then minus 29 squared. Yeah, because this expands to mn minus 29n plus 29m minus 29 squared. And this part over here is 0 because of this equation. Okay, so each of these is a factor of minus 29 squared. Minus 29 happens to be a prime. m and n are positive integers, so this factor is definitely positive, and this one is negative. This is, so n is not 0, so this is bigger than 29. So we're not looking at minus 29 times 29. Okay, so the possibilities, I guess, to be more explicit, is minus 29 squared and 1, minus 29 and 29, and then minus 1 and 29 squared. So in this case, we would have, well, m is minus 29 squared plus 29, which is already not positive, and n is minus 28, so that's bad. In this case, we'd have n equals 0, which is bad. So we must be in this case where we have m minus 29 is negative 1. And so m is 28. And by the same token, n is 29 squared minus 29. And then the question, so we have to answer the question that they actually asked, is determine m plus n. So m plus n is 29 squared minus 1, which is a number. I don't want to work out what, 900, 840, 841 minus 1, 840. Yeah. Okay. Okay. Nope. I already promised I'm not going to keep scrolling back up. I'm just going to repaste the questions, and then I already broke that promise. In trapezium ABCD with AB evenredig. Guess that must mean parallel to CD. The corner lines intersect at P. Or hoeklijn at the diagonals. Let's pretend it is. It's great that it's very literal, so even if I've never seen the word before, I can figure out what it means. Hoeklijnen, corner lines, must mean diagonals, right? And evenredig, equally wide, equal distance. I mean, I guess that's like referring to how parallel lines stay the same distance apart everywhere. Also not actually a word I've seen before. ABCD, AB parallel to CD. And then these lines, I hope, intersect in P. Well, I guess there's the possibility that they mean the ones outside the trapezium. If the area of ABP is 72, I've got a feeling that looks like it's going to be the bigger numbers. I've probably drawn this badly. And CDP is 50. Yes, this is definitely the right way around. AB is obviously the shorter side in all of this. 72 and 50. Determine the area of the trapezium in centimeters. Well, okay. If we, I guess let's call this X and H1, H2, and Y. Then the equations that we're given here is that a half of X times H1 is 72. And a half of Y times H2 is 50. That's not going to be enough information because I was going to say what we want to work out is a half of X plus Y, H1 plus H2. But to work that out, we'd need X times H2, which we don't have. Okay, so how can we decompose this in a sensible way? These triangles are similar. Yeah, I guess that's the other, that's the important consideration. Is that, yeah, if you imagine that this angle is equal to this angle, basically. So these are the corresponding vertices in these triangles. So you end up with, rotate this blue triangle 180 degrees around and shrink it. because the blue triangle's bigger, clearly, as you can see in the picture. So shrink it and then it will match the other triangle. So that means that h1 over h2 is the square root of the ratio of the areas. Because when you scale a triangle up by a certain factor, you get the area goes up by the square of that scale factor. So this is the square root of 72 over 50. Which fortunately a 2 cancels from both of those. That's 36 over 25. So this is just 6 over 5. If the screen would stop messing around. Equals. I give up. Computer is not my friend today. Okay. And oh, and x and y is in the same ratio. But yeah, so yeah, x over y is also 6 over 5. So x is 6/5 of y and h1 is 6/5 of h2. So this is a half of 6 over 5 plus 1 times y, and then 6 over 5 plus 1 times h2. Yeah, because x is 6/5 of y and h1 is 6/5 of h2. And so this is a half of y h2, which we know is 50, times 11 over 5 squared. So it's 50 times 121 over 25, which is 242. I think that's correct. Okay, ABCD in the figure is a rectangle with an inscribed semicircle on AD. Semicircles AE and DE touch each other at E or are tangent at E on AD. And ABCD underskadelijk. I should know what that means. At point A, respectively, probably. Yeah, so they are tangent to each other on AD and to the rectangle ABCD, respectively, at A and D. Both BE and CE are straight lines. If CD is 2 and AE is DE, CD is which one? This one. This side is 2. No, I do not want to move it. That side is 2. And that is equal to that. And that's all we're given. Determine the total area of all the colored pieces together. Okay. Semicircle. 2 semicircles. This side is 2, which means that this radius is 2, so this is actually 2 squares of side length 2. And then we have 2 straight lines that cut the squares in half. And then I don't even know which pieces are colored. This thing, this piece. Oh, this is not over there. Then this piece up here. Oh. No, that was wrong. It's this piece over here. So you get a checkerboard pattern. Sort of. And I want all of those pieces together. Did they just fit nicely together to make some full shape somehow? Yeah, I really don't know. I This is horrible. What am I missing? Okay. This piece, I guess. You do that. That, I guess. This piece does not reflect nicely. Yeah, I'm like wondering, how do you work this out? Because it's not like this is possible because this is just half, or like it's a square minus a quarter circle. For this piece is a square minus the quarter circle. So it's just this piece that's annoying. So where does it come from? What can we do with it? Does it? Is this the middle? Yeah, this is the middle of the square. That's interesting. Let's draw the square there. Cool. And that is the center of the square. Um, like I'm wondering, does this piece fit in like over here maybe? I mean, it does, but what does it look like when you do that? Come on. I don't like this question. Maybe. Divide it up even further. This is a quarter circle over there. This is a triangle. Um, this is... It must be a more efficient way, but you can work out... This is... Yeah, there must be a better way, but I mean, we just want our answer, right? So it's... You don't have to do it elegantly. Yeah, for the lack of anything better. Okay, let's cut it up into these pieces. So this is a square of side length 1. Oh, yeah, yeah, that's fine. But that piece extends above the... Never mind, that's not going to work. Oh, we know this piece over there. We know this triangle. So then we know the area of that piece. We know the area of that piece. Then we need the area of that piece. Yeah, so this colored section over here is a quarter of a circle with radius 1. So this one has area a quarter of pi. This shaded piece over here is a right angled triangle where the two side lengths are both 1. So it has an area a half. Then we know we can work out the area of this over there. Do we need that? Yeah, because we want this eighth of a circle over here of radius 2 minus this circular cap. So this circular cap, let's give it a different color, cyan. That is going to be a quarter pi minus a half. That's not very visible. And so for this piece over here, it's going to be an eighth of a circle of radius 2 minus the cyan region. So that's 1/8 of pi times 2 squared. So that's a half pi minus a quarter pi plus a half. So its area is a half, so quarter pi plus a half. Yeah. And then this piece over here is half of a square of side length 2, so a half of 4 minus a quarter of a circle of side length 2, of radius 2. So a half of 4 minus pi. So this is 2 minus a half pi. Okay, and then we want the orange plus the purple plus the blue plus the red. So all in all, we've got the orange was a quarter pi plus a half. And then the purple is plus a half. Then the blue is plus a quarter pi. And the red is 2 minus a half of pi. And everything involving the pi's cancel as they have to, because the final answer is going to be an integer, so we're not going to have pi's floating around anymore. And so we're going to get 1 plus 2 is 3 for this half of the figure. And then another 3 on the other half is 6 in total. It feels like there must be an easier way to do that, but doesn't matter. We've got to answer. And then the final question, two different positive integers a and b satisfy the equation a squared minus b squared is 2024 minus 2a. How many pairs of integers satisfy the equation? Oh, wait. Yeah, how many pairs of numbers? Okay, that question is technically ambiguous. Although, yeah, it's implied that what I really mean to ask is how many pairs of distinct positive integers satisfy the equation. But technically, the sentence asking the question just says how many pairs of numbers satisfy the equation, and then ignores the previous restrictions that they imposed on the numbers. Was it minus 2a? It probably doesn't even matter. Yeah. I mean, it looks like you just want to bring this across and then do difference of squares, and then you've got a factorization equals a number, and so you try all the factors. This is a plus 1 squared minus b squared is 2025 after adding 2a plus 1 to each side, which if you don't know is 45 squared. So that's 9 times 5, so it's 3 squared squared, 3 to the 4 times 5 squared. And so this is a plus 1 minus b, a plus 1 plus b is 3 to the 4 times 5 squared. And so these are just factors of this number, except that we want positive factors because this is positive. If a and b are positive, we want them to be this is clearly the smaller of the two numbers. So in each pair of factors, the smaller number is equal to this bracket. The larger number is equal to this bracket. You'll be able to solve the equation because you'll get a plus b equals something and a minus b equals something. So this always has a solution. You can add them and then divide by 2 to get a, subtract them and divide by 2 to get b, but the restriction on that is that these two factors have the same parity. And so as long as they have the same parity, you can solve this equation. Now this is guaranteed because this only has odd factors. Has odd factors. So the only restrictions now is we don't include the pair 1 times 40, 1 times 2025, because then A will equal B. And in the version where we have 45 times 45, we're going to get B is equal to 0. So there's one solution for each pair of factors. Pair of factors d1, d2, such that d1, d2 is equal to 45 squared. Except 1 times 45 squared, because in that case we get that a equals b. Squared, because this gives us a equals b, which we were told to exclude because we said they're two different integers. And also accept 45 times 45, because that's going to give us b equals 0. Okay, so the number of factors of this number is 5 times 3, so there's 15 factors. So that's 7 pairs, and 7 pairs where there are two different numbers, and then the 45 times 45. So we have the 1 times 45 squared, 3 times whatever 2025 over 3 is, and so on. So 7 pairs, and there's one extra thing where we're multiplying by itself. And we're excluding one of these, so we've got 6 valid pairs because we have to exclude 1 times 2025. And so yeah, the solution to the final question is also 6. That's weird. Hopefully I haven't made a mistake anywhere. No one's asked any questions or made any objections, so I assume that everything was fine. But I think I'm going to stop there. And I mean, there is more to say on this. There always is. I could give examples of other problems where you have to do similar things, like this kind of thing where you want to factorize as a difference of squares and then count how many factors there are and get a solution. Has shown up in multiple places before, like the 2016, I want to say, might have been 15 Pan African Mathematics Olympiad, at a harder version of this, but essentially the same thing. Difference of squares, factorization, and count how many factors a number has. Various of these things show up quite regularly. Like the thing with Jack and Jill. Jack wants to get to Jill's house. How many paths are there? How far back is that? Where you want to fill in, I guess the general technique here, if you, well, I don't know, mathematicians don't call it this, but competitive programmers do. Dynamic programming. I guess the fancy mathematical term is just recursion. Although recursion is a more general concept, or yeah, it's less specific of a technique. I don't know if there's anything else that stands out. I sort of like know straight away that this is x plus y cubed, but if you haven't, I don't know, maybe that's not something you spot easily. And the one that goes 1, 4, 6, 4, 1 is the fourth powers, and 1, 5, 10, 10, 5, 1 is the fifth powers. Beyond that, I don't know if I'd recognize them straight away, but yeah, the cubes I'm fairly familiar with. Yeah, I don't know. There's not that much commentary that I can add at this point. So I think it's probably, yeah, you can, this one, like I said, the Josephus problem is a famous problem. So the more difficult version is, what if there were, 2024 people originally in the line? And then you can set up a recursion for, you reduce it to a similar problem, because we saw that all the even numbers drop out originally. So then we're solving the same problem with 1012 people. Now we know, if we had already solved a problem for 1012 people, we can do it for 2024 people by remembering that the person in, say, position 7 in the 1012 would be position 15 in the 2024, because they correspond to the odd numbered people in the original problem. So you'd have to adjust the answer you get, but you can break it down to the same problem but with half as many people. So you're solving log of 2024 versions of the same problem. Or not really, because each time you're doing a constant amount of extra work to uh, go from the one case up to the next one. But it's much more efficient than simulating the thing. Like I said, you're doing like log of 2024 steps instead of 2024 steps, which, well, is a much smaller number. That's kind of the point. Uh, this thing of usually they don't ask what's the biggest power of 2. Usually they'll ask like how many zeros are there at the end of the number, which turns out to be the same question as how many powers of 5 divide the factorial, but that's something that's quite common. This only looks hideous, but like once you actually work out the individual terms, the cube root of 8 is 2, and then it just simplifies. It's just 2's all the way until you get to the 3 at the end. This, I'm not sure what they were expecting people to do. Like I said, if you already know that the answer's 2, it's not difficult to show that the answer's 2. But if you don't already suspect that the answer's 2, then I mean, it's not that far out of the question, but it is a bit weird to put it as question 4. Maybe not, I don't know. Yeah. Anyway, hopefully that was interesting and or useful. I'm going to stop there. Goodbye.